Okay,
What am I
so
looking at?
all right, so right now we're just at a my own user home screen on GitHub. So GitHub is just a website that hosts Git-based repositories. And a repository is basically just a folder, just files, just a folder of files. But with one special feature is that the files can change over time. So it's not a snapshot of a folder. It's a whole history of a folder, if that makes sense.
So you're saying that it has the addition plus the before. It keeps the history and then gives you the new snapshot.
Yep, exactly. So whatever you happen to be looking at in a repository is the latest version of all the files in that folder. And you can, when you delete something from that folder, it doesn't actually go away. The old history still stays around. All that happens is that it's now just no longer part of the current snapshot.
So you can delete the latest one and not
So
delete the
you,
whole thing.
that's right. So if you delete everything, it didn't actually go away. You can say, "Oh, I want to go back in time previously, and now I want to look at it here."
Okay.
And so Git is not the first revisioning repository created. There was a whole history of revisioning repositories. They're very useful, as you can imagine. You don't want to break things that are working, but you need to make changes constantly. So it doesn't matter what you're working on. It was a lot of programmers, but also artists use it. Designers use it. So anybody that's working on uh, file-based programs, file-based anything, it's super useful to be able to go back in time to what was working at one point, and then keep iterating forward onto new stuff and new stuff and new stuff. So Git kind of added some novelty here, where for one, they don't store the folders themselves. Git does not store folders. It only stores files. So we'll get to why that maybe can cause a little bit of confusion, or workarounds around it. But basically, also, each file is tracked itself. So the snapshot basically is the current snapshot, and that will have some random ID. It's not totally random, but it looks like a random ID, usually alphanumeric numbers and letters, gigantic string of digits and letters. That ID is just like a label, a way for Git to mark that snapshot. And so every single time you make a change, the whole snapshot will have a new ID. So that it's pretty cool because it basically means you can go to any snapshot in time, and that will it will always have a definitive label. It will always have a definitive ID in time. So you make one change, each of the files might change, but the overall snapshot will have an ID at the end of that. And each time you make a change, the ID will change, ID will change. But it just makes things really convenient. You don't have to worry about individual files because the individual files will also have their IDs change over time, but the whole repository will get an ID at each time spot. So there's a few layers to it, and we'll try to dig in a little bit. So we'll try to keep it simple, but basically it's just a folder, and each of the files is tracked individually in that time sequence, and all the files at a specific time also has its own ID. So those kind of things just make it really useful to use.
Okay, let me see if I understand. You have a folder, and what's the folder called in GitHub?
The root one it can be whatever you want, but we'll just call it a repository.
A repository. So
Yeah.
your folder's called a repository.
Every Git interaction is based on one repository. You can make new repositories, you can keep making new ones, but it always starts with a repository.
And then repositories have files.
Yep, that's right. A repository will have files. And that's
And
pretty much it.
GitHub tracks files.
So GitHub is a web viewer of a Git repo. So GitHub can help you track all of your repos in one central place. So it's like an online storage of Git repositories. They just make it really convenient because when Git started, you can do all of this locally on your computer without GitHub. You can do the exact same thing locally. It's just more work because there's a command line. There wasn't the graphics, the viewer wasn't really there. It was just a command line. So it was like more towards programmers and us nerd folk that knew how to use these things. So it was GitHub that kind of created a visual web-based version of the Git repository system and then offered it for free basically to anybody that wanted to put their code on the internet. So it was really convenient. Yeah, looking at my screen, anytime you go to just github.com, you're going to see something like this.
Yeah.
It might look a little bit different because I have some repositories. I already have a user logged in here. So if you don't have a user, it'll look a little bit different. But once you log in with your email password, it's going to look similar to this, where you have the right-hand side has all of your personal profile repositories, things to look at. The left-hand side is just a little quick glance view of your user and stuff, of your different groups and stuff. And these are pretty much the same. So there's not going to be too much difference here. I guess some more tools or whatever, but it should look very similar. And the main thing that you're going to do if you don't have any repositories yet, the only thing pretty much you can do is this new repository button. If you don't have any repositories, all you can do is make a new one. So I guess that's where we'll start because that's the most important thing. Most of the other stuff doesn't really matter yet. So we'll just go into new. We can walk through these settings. Most of them are not really that important other than the name. So the name is the most important part of the repository. Obviously, the owner is going to be you when you're creating a new repository.
Yeah.
For me, I have organizations that I can create inside of, but for most people, they're just going to have their user, and then you can have repositories that you're going to make here. So it doesn't matter what the name is as long as it's not taken, whatever we want. All right, so this says test repository is available, whatever. Description doesn't matter, it's optional. You don't need to put anything. Public and private are up to you. I think GitHub has a little bit more restrictions on private repositories. They start charging, I think, for some of the private features. So if you keep it in the public, then you'll get pretty much everything for free. A README file is, again, it's optional. Essentially, it's just a way for people that come and visit your repository to kind of get a heads up on what it's about. So we can always create one later. You don't need to create it right away, so don't get scared. If you do add it, you can always modify it later. It's not going to be there forever. You can change it. We can just start without it right now so you can see kind of what happens if I just don't do anything. This git ignore, again, totally optional. But if you do use it, all it does is it doesn't really matter what I choose. These are all just suggestions. These are like pre-known file filters. So essentially, a lot of these will be development environments. So if you are developing in Go, in the Go language, or if you're developing in a Gradle language, or here, we're developing GitHub pages. So this is what we're going to kind of use today anyway. So why don't I start off with this? Or none. I'll just start off with none. But just know that all this .git ignore does is when you're going to go add files to this repository later, this is like a filter that says, you know what, that's just noise. That's just noise on this person's computer. We don't want it to be saved forever in the repository. So like if you have like a passwords file or something, you don't want to put that passwords file into your repository. So you can put the passwords file in your .gitignore file. And then when you go to add a file to the repository, it will say, oh, no, that's a sensitive file. It's ignored. We're not going to put it in the repository. So
it's git ignore.
Yeah, so it's signaling to the Git repository, actually, we don't want this kind of file in there. That's all. So I'll start with none right now. Basically, it just means all files are allowed. Git is not going to prevent me from putting any type of file in here. it's not going to prevent me. So we can just start with that. And then same thing, license. It gives you a handful of licenses you can start with. But again, all this you can add later. Same thing with the git ignore. You can add later. You can change it. You can delete it.
Where do you get a license?
So these are just like the built-in ones that GitHub provides out of the box, but there's no requirements. So you can start with no license and you can add one later.
Yeah, okay.
And or you can choose one and you can remove it later. Okay, so it's just a file that gets created, because all Git is a bunch of files. So all these three things are: the README is just a file called README, the git ignore is just a file called .gitignore, and the license is just a file called license. So it's not very sophisticated or anything. It's just
but if you think all that matters, then it can confuse you, right?
That's right. Yeah, if you go and look at it for the first time and you're like, this looks like I don't know what I'm doing.
I have to make a choice and I don't know what these things are.
Exactly. So they're literally just a couple files that it gives you for convenience. If you need the convenience, it will give them to you. So that's all that is. All right, so we did create the repository. So we get to this first screen so it says test repo up here. That's what I named it. But there's nothing in it. There's nothing in the repository. So this is kind of like a blank slate. It's like, hey, we don't have anything here yet, so we're just going to show you some basic about information. So here's a quick setup. If you've done this before, here's some things we can recommend. The license, the README, we've already talked about. The git ignore, we've already kind of talked about those things. So, or you can create a new file or upload an existing file, right? So this is brand new. There's nothing here. All that we did is just create this, and this is just a blank slate, just some suggestions. This kind of suggestion here kind of brings you back to the old school where it came from. So if you were an original Git user and you didn't have GitHub, this is how you did it. The thing that we just did right now, when we said create a new repo, is called git init. That's all we did, was called git init. And then the next thing we probably are going to do is called add a file, right? So one of these options, either uploading a file, creating a new file, it's just going to git add the file. And again, that's only going to change it to my local area. Then I still have to commit it to Git and then push it to Git. So all this stuff is like very complicated to understand when you're first encountering the stuff. And it doesn't matter to most people. You don't have to know all this stuff until you start getting into the weeds of it. So this is kind of overkill for a first encounter, because all we've done is just created this repo and there's literally nothing in there. It's just empty, sitting there, nothing to do with it. Okay, so I can even like leave and come back. So if I go here, what's going to happen? Okay, I go to my repositories. Oh, I see this test repository at the very top that I just created. I have other repositories here, but the one that I just created 2 minutes ago is on top, right? So if I go back into it, it's going to give me this blank stare. This is just a blank stare. Like, I don't know what you want to do here, guy. Like, you make the next move. So we got to do something next. And really all we are doing is adding files, right? So this is the whole point of this, is just adding files to a repository and then changing them over time and seeing that you can go backwards and forwards. So now that we're here, we can.
Can I ask you a question? Please. What are those? The create is that something? Create a new repository on command line.
Yeah. Okay. So remember, this just happens to be in the cloud. So this is just running on somebody else's computer. That's all that means. Okay. Somebody else's computer is where we just created this repository. This git init was done on somebody else's computer, and it's just sitting there waiting for new commands for us. But if I wanted to, I could do what I just did on my own computer. So if I shared a different screen, but basically we could go onto the command line, and you can download the Git command line interface, and then you could type on the command line git init, and it will just, whatever we call it will be what it gets called when we get init. So this is just things that you could do locally instead of on somebody else's computer, which is GitHub is just somebody else's computer.
So I'm probably not going to use that.
You should not need to. Yeah, this is usually when you start working in the same repository with other users, you can run into conflicts because I can make changes locally, somebody else can make changes on their end, and we both want to get them into this central place on the main computer. Either it's GitHub or some other location where the repository is living. And so then we have to resolve conflicts. You know, there is a lot more complexity behind Git itself because it's a really powerful revisioning tool. And the person that made it didn't need to make it convenient or easy for other people to use. So it is pretty complicated when you start digging into like, how is this actually working? Or like, if I want to do this locally on my own machine without GitHub, you might have to learn a bit more complexities behind Git itself.
What does push mean?
That means you are actually finalizing the change. The way this works is you could make a lot of intermediate changes. So you could say git add, git remove, git add, blah, blah, blah. You can git commit a bunch of times. You can do it a bunch of times, and it won't actually store that. It won't actually put that ID, what I was talking about earlier, how then the snapshot in time. So that snapshot in time won't get an ID until you do the git push. So once you do a git push, then the repository gets a new snapshot in time, a new ID at that time. You can always go back to the previous one, but that push is what marks it as this is now a transaction that's been completed.
So will it be the last thing that you did, or will it be a combination of all the things you did?
It will be everything you did since the last push. So everything that you did previous to the last push will be accumulated down. And then when you do the push, all of those things go in at once, like one transaction. So all of the intermediate things are almost irrelevant. Like you could throw them away at any time and it won't affect the bigger picture. It won't affect the repository. So that push is a signal to the repository to actually go ahead and do whatever it is you're trying to do. Everything else was just set up to that point. It's good to know kind of what's going on, but yeah, you generally are just looking for a few things, and git push is one of those important things. It's like, I've actually done something official to the repository. I've marked it as changed. It now has a new ID, and that's it for that repository. And you can keep pushing and keep pushing and keep pushing, but that just pushes it forward in time.
So what it means is I can play in the file and do anything I want. And then when I'm finished, then I do a push, and that makes it real to the repository. Up until then, it's just the shit I'm thinking.
Yep. It's just to help you track your progress. You can still interact with your progress against the last official push up until the time you do a new push. And then now you go forward in time. And now once you've pushed, if it goes through, you are sitting on the latest repository snapshot, basically. That's the latest official. And if somebody else, like, this gets complicated because if somebody else pushes onto the repository, then now you're a little bit out of date, right? It looks newest to you because you don't know what happened on the GitHub official repository if somebody else pushed to it. So then if I try to push to it later, Git can say, whoa, you can't push that because somebody else pushed it and you have an older one. So it's good to know that the repository is a official one space. It's like one official thing, and you can pull down, they call it syncing, I think, SYN, or cloning. So you can clone or sync, but basically cloning or syncing is taking a repository locally onto your computer. That's something that you're going to want to do to like modify it, edit it. Sometimes, like if you can't make the change directly on GitHub, you'll pull it down, you'll sync it or clone it down to your computer, you'll modify it on your computer, and then you'll want to push it. You want to get it back up into the repository. And there's different ways to do that. Like one can be the command line, but one will be through like dragging and dropping. And so this is just, we talked about a bit of the basics, but this is still just an empty empty shell, just waiting for us to put files into. So that's what we do next. So we can either create a new file or we can drag and drop an existing file. So I clicked upload a file. We can always undo this. So we go back here, it's empty. We go upload an existing file. This will be like a nice drag and drop interface that says, oh, just take any file off your computer and just drag it here, right? So that's nice and convenient, or you can choose files, right? And you can select, or we can go back and create a new file. So if we're creating a new file, it's just like a blank, oh, hey, you want to create a new file? Hello. Whatever you want to put in this file, this is just like an empty canvas. It's just like a convenient text editor for you to use this global web-based text editor instead of your own computer. But at the end of the day, what you need is a file name, so we can call it whatever. The README is like usually often the first file is like a README here, but it doesn't really matter. You can call it whatever you want. Hello.txt. You can name it anything. It's just a file. And this is just one little note. Main. So one thing we haven't talked about is this concept of branches. And we don't have to get into the weeds on branches, but it's just good to know that all repositories have an unlimited number of branches inside of the repository. There's one main branch, generally speaking. The main branch is the one that is your newest often. It's the one that you care about the most. You can change the name later. It doesn't have to be main, but it defaults to main. This is why this little main word is here, is because it's signifying the branch name that you will be putting changes onto. So branches always have a name. So this branch is called main, and that's the main one. It's the default one, basically.
Is it the trunk?
The trunk is a way to think about it, but just know that it doesn't have to stay the trunk. Later, if you want the trunk to be called Bob, you can make the trunk called Bob. So it's just the first trunk. It's just the original trunk.
Do all the branches connect to this?
When you first start off, I would imagine, yeah, you start off with one branch. So it's going to be your first branch, but you could always create another branch. It may not be related to this one. They're not necessarily all connected. Yeah, you can start a new trunk inside your repository. It doesn't have to be connected to your original. Yeah, so they can all be disconnected if you want. You could have a bunch of trunks if you cared to.
So for right now, that's just telling me that all I have is a main, and so it's going to put it in the main.
Yeah, because it's the first one. And if we were doing it manually, like if I was doing this from my computer, from command line, like we saw before, if we were doing it from command line, you could choose a different name first. So I think if I'm going to go back here real fast. So in desktop here, does it say, yeah, here. So if you look at this line right here, so we were talking about init is what we just did. We just created a repository. We haven't even added a file yet. Before I do the push, I will have to set a branch. So the default is main, and that's how you switch the trunks. Basically, yeah, you can switch the trunks, and you can use a different trunk on this repository. But the default one for anybody that just goes into GitHub and tries to create something or drag and drop something, it's gonna be main. Yeah, it's just default, but you can change it. So it's just when you first start through GitHub, I don't see any way to allow you to change it right away. So yeah, you're just going to create into the main branch on your first interaction. Unless if you do the command line or something more complicated, you're just going to be going into main the first time. So if we just do think through because it's inconvenient. I thought it was going to be faster. So we don't really have any other options here. It's got some interesting explanation, and you can change the way that it indents, how many times it indents, and if you don't want line wrap or if you want line wrap. I don't know. For programmers, this stuff is convenient. If you're a Python programmer, you want everything in tabs. If you're most other places, you just want spaces in your indent. And that just means if I hit tab, when I hit tab, it goes that many spaces. So tab is just an easy a common thing for programming use cases. Having the number of spaces in the tabs being consistent is just a convenience. So GitHub's tracing its origins back to programming. It says, we're going to help you. This is a little bit convenient. Okay, so committing the changes is the only option at this point. You can either cancel them or commit them. Cancel just goes back to what we're doing. We can always add another file later. So I'm just going to go ahead and commit the changes. So it's giving you a little optional. All this stuff is optional. Again, so this is optional. If I don't put anything here, it'll still let me do it. But it's a way for me to know, or other people to know that look at my repository, why are you doing this? Why are you adding hello world? Why are you adding this file and not any other file? You can put a description here if you're being kind, and you can say like exploring GitHub or whatever, you know, like creating a new file to tell the world hello. Well, it doesn't, but it's optional. We can see where it goes. So committing. So now you have a file in your repository. So now you see this little ID pop up here, what I was telling you about earlier. This right here is that alphanumeric code ID that my repository on main branch has been marked with. It's actually a much bigger code. Just for fun, I'm going to click on it and see where it takes me. So you can see it says this was the commit described. This was, this is the description. This is what I said the name was, right? It has no parents because it's the very first trunk. So there's 0 parents means it's a trunk, right? And this commit is actually, it's a much longer. I was trying to find the much longer. If I copy this and paste it, oh yeah, here it is here. So okay, this is actually the ID. If you look at the top, so this giant, it's called a hash or a SHA. This hash is the kind of the ID for this repository in this snapshot with these files. So it contains the latest of all the files in the repository is identified with this commit, saying that I might have said this a little bit wrong, but we'll see. So if I go back to my test repository now, yeah, so here's the latest commit that I made 1 minute ago. This is what it was called. So it's just giving me, and here's a description of it, and here's the file, and there's no README yet. So it's like, oh, do you want to add a README? Because a lot of repositories have READMEs, and yours doesn't. So this is just a helper to tell me, oh, I can add a README file or whatever. But for now, we see that there's one file here called hello.txt. This is just a viewer. I can go to the raw file and it will just be the raw file. I can download the raw file. So it'll just download that hello.txt file, or I can edit the text file. So now if we say whatever we want to say, right? So here, again, this is hello.txt. That's the name of the file. It's in the main branch. So we can cancel the changes and do nothing. Or I can commit the changes. We're having fun changing files. And now you get a second option popping up. So before all we were doing is committing directly to the main branch. And that's probably what we're going to be doing most of the time. So most of the time, you're just going to want to stick to a branch, and you're going to want to keep editing the same branch over and over and over and over and over and over. However, if you're like, wow, this is a totally different direction, or like I'm making a big risky change right now. This is a sensitive change. I really want my old stuff to be there. I don't want to stomp over my old stuff. I liked my old stuff. You can create a new branch, and that's going to create a new trunk. But it could come from, actually it'll come from this one, I think, because we're not starting from scratch. We're starting from something. So it'll pull the old information, it'll pull the old ID. It'll say this was from this ID, and now we're going here. But all this is details, right? So the important part is it doesn't really matter. This is a new branch. Or you can just keep committing the same one. So I'm just going to keep committing the same one to keep it simple. Okay. So now if we commit to the same one, okay, here. We don't want to use pull requests.
What is a pull request?
Talking about earlier, where Git starts getting complicated, because again, this is just on somebody else's computer, right? So the cloud is just somebody else's computer. So this repository is living on somebody else's computer. So what ends up happening is if there's two people trying to use someone else's computer, they can be out of sync. So if I'm making changes and then I want to push onto the cloud, onto somebody else's computer, then it might let me do that. And then somebody else will be now out of sync. So now if they try to push to the cloud, it won't let them. It'll be blocked. It'll say like, hey, you have changes. They're out of sync because one person already changed that and you don't know about it yet. You don't have that in your timestamp history. You don't know about this thing that already happened. So we have to block you. So this is the complexity of Git and maintaining one single linear history. It has to block new people from putting changes if somebody else already put changes before they're ready yet. The complexity there is there's two ways to do this. One is just called force pushing. So what we saw before that push command, there's a way to push the command forcefully. And it says, I don't care what anyone did before me. This is what you need to know. And then it will take all, because I still had to come from one history, right? In order to get to where I am, I still came from one history, but it's dangerous because if somebody else made a change and then I push with force, I do a force push, it just discards anything else anybody put. So this idea of force pushing is a little bit risky or dangerous. So this alternative is this PR. So PRs are pull requests. Pull requests are kind of this way to centralize changes coming into your branches. So it's basically a holding space. So a pull request is a specific change being made on a specific timestamp. So most of the time we're on the latest timestamp of main. So if we're being really specific, we're on like the main branch. We're on a specific timestamp in main branch. And so the pull request references something like that. So the pull request has to reference what branch you were in, what timestamp you're in, and now what differences are you trying to make. So a pull request has both of those pieces. It has where you want to go and where you came from. So that pull request is just a request to apply that change onto that timestamp, because we want a linear history. So a pull request is just like, hey, I would like to make this change. I can't do it. I don't want to do it forcefully. So I'm going to let GitHub manage this change. So it allows me to stage, in a way, it's like staging a change to be made. And so this allows teams to kind of gatekeep what goes into those branches. It prevents people from just force pushing and then breaking somebody else's change that they spend all week on. So the pull request is just this intermediate step, this kind of staging area, this intermediate step that says, hey, I would like to put this on the branch, but I can't just forcefully put it on the branch. So this pull request is kind of the process to do it. So I want to just disable this. It seems like GitHub is broken right during me trying to teach it. But it's hard to imagine that's the case because GitHub's uptime is pretty impeccable. Is GitHub down? GitHub status. Is that real? The down detector is saying that it's down right now as of 11:10. We're literally recording during like a massive Git outage. We literally broke GitHub. No, I'm just joking.
We have the power.
Look, wait, I can't show you from my phone, but wait, I can show you from my computer though. Here, let's check this out. This is wild. This is really wild. No, this is cool. This is crazy. Watch this. Look at this. Look at this map. Do you see that?
What is it?
This is GitHub going down right at like 11 a.m. and it just started peaking. I mean, you can see like GitHub doesn't go down. Like, well, at least not in the last 24 hours. Yeah, we had good timing today. I was very confused as to why my little silly changes are having such big issues, but I think Microsoft must be having a little bit more problems than me.